God. Morning, Observability fans. Straight off the bat, it's never ending. It really is Groundhog Day. I learned something this morning, okay? Took me about 30 seconds, right, to learn the Pythagorean theorem, right? Now, this has to do with lasers on the moon, absurdities, and people not being intelligent enough to understand that they're not intelligent enough to understand the science, right? This is how you learn things, right? For me, this was common sense, purely common sense. I looked at a picture, somebody sent me a picture, this was about 5 or 6 weeks ago. It was to do with the lasers on the moon. Your favorite space agency left laser reflectors up there back in 1969, between 1969 and 1972, and they use these reflectors to bounce lasers off and stuff. No, they don't. There's no reflectors on the moon, I'm saying, because they haven't been. And then this guy drops a picture. Boom, right? And I'm going to show you in a minute. And it's a picture of a green laser going up from somewhere in the US, obviously, up to the moon. And then there's another laser coming down. So it looks like the laser goes up, hits the moon, and bounces down. Now, I thought that they were showing a laser going up and then coming back down to Earth. So I said, guys, I used my common sense in about 10 seconds to say, don't be ridiculous. It's impossible, right? Because where the laser's coming down would be hundreds of thousands of kilometers away. So I just had a closer look, because I've been talking to somebody else about the lasers that don't exist, not the lasers, the reflectors that don't exist on the moon. It's ridiculous. And I had a look at this picture, and I saw it was the same picture that guy had posted to show me. Now, I didn't realize that there was a picture of your favorite space agency banging a laser light up to the moon. So on closer inspection, reading the fine print, the small print, it says, this is an image, a photograph of your favorite space agency bouncing 2 different lasers up to a lunar orbiter, right? Now, it doesn't change anything. It's about, for me, this was instant common sense. I can look at the angles. I don't know about this Pythagorean theory, but I had to learn it to show what I'm talking about. I thought it was common sense. So I had to use the Pythagorean theorem. 2 seconds. All right, that's the after. Oh yeah. I had to find a way to prove that what I'm saying, right, was correct, is correct. I thought it was common sense, so I had to learn how to use a theory to prove that it was just common sense, right? That I wasn't far off the mark at all. Now let's have a look at it's this, right? Now, it clearly says this is a photograph of your favorite space agency bouncing 2 lasers off of the moon, right? But not off of the moon. There is a lunar orbiter somewhere there, okay? Somewhere near the moon. Obviously it's near the moon because both lasers are pointed at the moon. Now, I looked at that when this guy dropped just the picture and looked and went, nah. I said, this is rubbish. I said, if you work this out, nah. And then I left it, right? And then was it last night? I was sifting through, I've been talking to somebody about the lasers, and I saw this image. And I thought, shit, it really is, and it says so. It says, this photograph shows a laser ranging facility at the Goddard Geophysical and Astronomical Observatory in Greenbelt, MD. The facility helps NASA anyway, look, yada yada. And it clearly says, here, scientists are using the visible green wavelength of light. The laser facility, hang on, no. Both beams shown coming from 2 different lasers are pointed at NASA's Lunar Reconnaissance Orbiter, which is orbiting the moon. Right. is coming from two different lasers. It clearly says that, okay? Now, I wanted to know, straight away, let's just put this image up here, right? This to me is common sense. This is what I say when I say, you just have to look at these things, right? So we've got the moon up here, right? And we've got this facility down here, right? So, whatever, right? And that's all we see here. And then we've got another laser light. So, we've got one laser light coming up here, right? It's clearly going to there. And then we've got another one that comes down at just over a right angle. And it stops about there, because that's as far as you can see in the picture. Right. It's obvious that this laser is supposedly coming from something on planet Earth, right? Because it's two lasers pointing at the Lunar Orbiter. Now, I looked at this and thought, what a load of rubbish. I didn't have to know, I didn't have to see numbers or calculations. Instantly, I know that the distance from here to here is on average 384,000 kilometers, right? So, we've got that distance once. 384, that's the average distance from here to the moon, right? Now, this other one, it has to be exactly the same because it's allegedly coming from planet Earth. Now, if this laser beam, it has to be the same length, give or take a gnat's whisker, because it's supposed to be on planet Earth, isn't it? So let's say it comes down here, right? Now I looked at this and went, no, I didn't have this part, but I can see it in my mind. And I go, this is ridiculous, right? Because with a right angle, this is a Pythagorean theory. Now I'd heard about it, but I've never, obviously in my entire life, needed to use the Pythagorean theorem. For what? But I did, to prove that this is just common sense. So I look it up once, and it says, this was about a right angle, okay? So when you've got a right angle, right, you've got a right angle, it's a right angle, 90 degrees. If you want to know the distance between 2 points, right, coming off of a right angle triangle, or any triangle, in fact, as soon as you know the angle, you can work stuff out. So the Pythagorean theorem says that with a right angle, this is side A, right? And it will be A squared and then B squared equals C squared. So this would be C, right? Now, I want to work out what this distance is, right? So what do? I square this dimension, that length, and that length. Because A squared plus B squared equals C squared. So if I get A and B, so, Alexa, what's 384,000 squared?
384,000 squared is 147,456,000,000.
Right, I was fast, I wasn't sure what was going to happen. So it's 147 million, 400, no, hang on, was it 147 billion? Alexa, what's 384,000 squared?
384,000 squared is 147,456,000,000.
Right, so this distance, which is 384,000 kilometers, because that's the average distance that we are away from the moon, it means that this side is also the same, because this laser, if it's on planet Earth, is also firing at approximately 384,000 kilometers. So we've got one side, that's it squared, so we add the other side, which we square as well. We know that they're both coming from Earth, right? And we add them together, and that will give us the length of C. So, Alexa, what's 147,456,000,000 divided by 2? Oh no! Alexa, stop. Alexa, what is 147,456?
147 is a number.
Alexa, what's 147,456,000,000 multiplied by 2?
147,456,000,000 times 2 is 294,912,000,000.
912 million. Right? So we know that this squared plus this squared equals that squared. So 294,912,000,000 is A plus B. We know that equals C squared. So now we need to find the square root of that. Alexa, what is the square root of 294,912,000,000?
The square root of 294,912,000,000 is 543,058.008.
Now, that image, that picture, that so-called photograph, right, of two lasers pointing at the moon from planet Earth, right, means, now this is with a right angle, right? Now that angle is further out, which means it's going to be a further distance. I looked at this when that guy dropped the picture. I did some calculations in my head with the distance, and I didn't know what the answer was exactly. So I said, I guarantee you that the end of that laser will be at least 500 and something thousand kilometers away, right? And it was only this morning that I proved that to myself, right? So that image of them bouncing a laser up to the moon twice from two different points on planet Earth is horseradish. When people say, where's your evidence? And I always say, the evidence is staring you in the face. This is exactly what I mean. So it took 20 seconds to learn how to use the Pythagorean theorem, right? And it's really quite easy. But it does, again, prove the amount of horseradish that people believe and the amount of science people think they understand that they obviously don't. Now, I actually used pi to try and show people the mathematical constant that it proves the sun does not radiate its light at a rate of 4.6 seconds per diameter. But you guys don't know what pi is. You've heard about it, but you've never had to use it. I've never had to use the Pythagorean theorem in my entire life, but I did. And luckily, it did show that yes, it is still just common sense. All right, guys, I've got a busy day today of other absurd science. Later, peeps.